Well, hello. What we're going to do today is the essence of differential calculus. Everything that we talk about in the first, really 4 or 5 chapters of the book, right? The most of the fall term is going to come from this picture right here. Now you can draw it with me, take a screenshot, Snapchat your friends, whatever it is you people do. But I'm going to go here. We're going to call this curve f of x. Now, on this curve are 2 points. The first point here will be a f of a. It's a friendly little point. Nothing intimidating about that point. Now, we're going to go a little bit to the right, or a lot to the right, depending on your perspective. Let's say we go out h units. So that distance there is h. I hope everybody can see that. My green pen is a little light. So that makes this point up here a plus h, comma, f of a plus h. Okay? This distance here is f of a plus h minus f of a. Don't you agree? I'll do that. Let me do that in black. I'm not feeling the green marker here. F of a plus h minus f of a. And although this is h units, how did we get that? Well, we did a plus h minus a, right? So h, which is a plus h minus a. Okay. Okay, nothing new there. Okay, this is a straight vertical distance, right? How do you find a vertical distance between 2 points, right? If this is 3, 7 and 3, 2, that distance is 5 because 7 minus 2, right? You with me? Okay. Now, but make no mistake, this is calculus. And what is calculus? Rhetorical question. Change. What is change? Oh, that's the derivative. Yeah. And what's the derivative? Oh, the slope. So wait a minute. Calculus is slope? Yes. And if you watch my other videos, you know this. It is all about slope. Only about slope. Calculus is about slope. And then we use the slope to try to describe what's going on out in the rest of the world. Calculus is about slope. Now, let's find the slope of the secant line that connects a plus h and a. What am I talking about? I'm talking about this line here. You guys see that red line? Okay. Okay, now, let's call the first point P and the second point Q. Our job, our goal in life, okay, we want to find the slope of PQ. Now, and here's what, so you might know what you're thinking now. You're thinking, well, I could just do that in middle school, right? Right? But here's the thing. As Q gets close to P, wait a minute. So what you're going to do is you're going to take Q, you're going to take this point here, move it on the curve closer to P. Well, what does that sound like to you? Does that sound like any concept maybe that you learn at the beginning of calculus, most of the time in a chapter 1, when something approaches something? Approaches something? Yes, a 5-letter word that begins with L and ends with T and has an M in the middle and 2 I's. Limit. We're going to take the limit. The limit is what? The limit is Q gets close to P. Can we say that mathematically? Here's your question. Here's your statement. As Q gets close to P, what happens to H? Pensez, s'il vous plaît.
Approaches 0.
Yes. H approaches 0. That is the key. In fact, that statement right there is the key to differential calculus. That's it. So let's take a dramatic pause here, because everything that I talk about this fall is based on that statement. As Q gets close to P, H gets close to 0. That's it. Everything else we do is algebra. Let's go. So then we say that the slope, well, middle school, y2 minus y1 over x2 minus x1. But then as Q gets close to P, I get the tangent to F at P. Whoa. Slope of the tangent to F at P equals, here it is, kids, the limit as H approaches 0, F of A plus H minus F of A over H. This is your life, and you know what we call that? We call that derivative, and we call that F prime at A. That is the slope of the tangent to F at P, or another way of saying at P is at X equals A. And that is called F prime of A. We're going to take a dramatic pause, and I want you to write that down and put it in your notes, because that is your life. It's called the limit definition of the derivative. The limit as H approaches 0 of F of A plus H minus F of A over H. That gives you the derivative. Now, how do we evaluate that? Algebra. And we'll do an example in the next video that works that out. And then what happens is you do enough examples and you realize there's a pattern. The F primes are related to the F's. That pattern is the formula for the derivatives. So there you go. Everything we talk about for the next 3 months is really based on that equation. So how about that? We're going to talk about one equation for 3 months. That's it. This is your life. Okay? Understand this picture, right? You got to visualize Q rolling down this curve to P, because when Q gets to P, then we have a tangent line, don't we? And our life is all about the tangent line. So I want you to think about that, and we're going to do a little practice.